All right, welcome back. Now, in the previous video, we learned how we're going to get our data. We're going to separate our data and then manually create our X train and then our X test and also our Y train and then our Y test, right? So we did all these right from the beginning all the way till we created this data sets, training and then the testing data that we're going to use to build our machine learning model. All right, so in this particular video, we're going to start by building our model, and as we are building a support vector machine, we're actually going to import this support vector machine from sklearn. So you can see from here we are seeing that from sklearn import SVM, right? That is import support vector machine, and then we initialize it over here, right? So you can see that we have we initialize it into a variable called model. Okay, then we have our svm dot svc, that is support vector classifier, because we have a classification problem, so we're using support vector classifier, right? We also have support vector regressor. So if you have a regression problem, then you use support vector regressor. So in this case, we have classification problem, so we're going to use support vector right? We're going to use support vector classifier. All right, so if we have a regression problem, then we use support vector regressor. All right, so in this case, we have a classification problem where we want to classify these letters, right? So we want to actually be able to correctly classify these letters using support vector machine. So you can see that we have C over here. C is nothing but the penalty, right? So that's the penalty. Remember that earlier on we talked about this penalty. If we go to our board, we say that each time a point crosses over, so if we put a hyperplane, right? So if we have our plane over here, right? So this is our plane, right? In this case, we use this one, this line over here as our plane to separate these two groups. So each time a point crosses over, right? Each time a point crosses over, we're going to actually add a penalty, right? So if a blue point crosses over to this part, we add a penalty, right? So we check the distance between that crossover point, right? And then the margin, right? The margin line, and then the distance over there is actually going to give us the penalty. Okay, in the same way, each time a point crosses over to this part, we check the distance from that point to the margin, and then the distance over there is actually going to give us the margin. So if it is 12, they give us the penalty. So if it is 12, this becomes our penalty, right? That becomes our penalty. Okay, so basically that's what we are seeing here. So this number 3 is actually saying that it's actually telling the algorithm, right? It tells the algorithm how much you care about misclassification, right? So if you put a high value, right? If you put a high value for C, then you're telling the algorithm that you care much about misclassification or classifying the algorithm, right? So it's going to give more emphasis on correctly classifying these algorithm, right? So if you give a low value, then its algorithm will know that you don't put much emphasis on the correct classification. Okay, so you can just tune this. This is just a hyperparameter which you can actually change by yourself, right? You can just see the documentation for support vector machine, and you can see how you can actually tune this. There are a lot of hyperparameters that you can actually add, right? You can actually change over here. So in this case, we're sticking to just this penalty, right? For understanding purpose, for simplicity, and then our understanding purpose. Now, after that is done, what we're going to do over here is to fit our model. That is making our model. Remember that we imported our algorithm, which is support vector machine. We initialize it to a variable called model. Okay, so we use model to fit on our training data, right? We use it to fit on our training data. So this training data consists of 16,000, right? Just like we did over here, consists of 16,000, and then later on we use the rest of the 4,000 for the testing. Okay, so we use model.fit, that is to learn from. So fit means learn, right? So it's basically learning from this S train and then the Y train data. All right, so after that is done, what we can do is to make some predictions. Okay, so our model has learned from the training and then the testing data, so we can now make some predictions. Okay, so we can now use model.predict, right? We're using model.predict here to make some predictions. and then we store it in a variable called ypred. Okay, we store it in a variable called ypred. So if you see what is inside ypred, you can actually see that we've been able to predict some letters over here. You can see that we've been able to predict some letters over here. Okay, and that is what we actually want to do. We want to build a model that will actually help us. If a new letter comes in, we can be able to actually predict that. Okay. Now, if you check the score of our model, you can see that we have around 92 or 93% over here, which is doing quite good, right? Which is doing quite good. And what I'm going to do over here is to compare the two, right? That is the Y test, that's the original letters that we have, and then the predictions that we made, right? So we made some predictions of some letters. So I'm going to compare that with the Y test, that is our target that we want to compare the predictions with, right? So we have, if you see what is inside the Y test, let me actually show you what is actually inside that. Okay, so let me actually add this over here. So you see what is inside the Y test over here. You see that we have some letters in there, right? So I'm going to put them side by side, right? I'm going to put the Y test, right? The Y test, and then the Y predict, right? And the predictions that I made, and then the original data that I have, right? I want to compare the prediction and the original data and then see how well I'm doing, right? So for that, I'm going to use this column stack to actually help me to stack the Y test and then the Y predict side by side. Okay, that's what I'm going to do. So if I pick say, let me do it over here. So if I pick, say, this is actually let me shift a little bit up. This is a prediction that I did. That's my prediction, and this is the results of my prediction. This is the original one. This is the test, right? So if I pick the first one, which is the test, I pick the test. The first letter there is N, right? And then I see that the prediction that I made is also N, right? So I'm going to put them side by side. The next letter in the original one is V, right? And then the prediction that I made is also V, so I put them there. The next one over there is I. Right, in the original data I also predicted I. Okay, so I'm going to do it. Don't forget, this is a break here, right? There's a lot of letters in there, right? So I'm going to do that. I mean, for all of them, right? For all of them, for all the other letters, I'm going to stack them side by side using the column stack. Okay, so that's basically what this column stack is actually doing over here. All right, so now you can actually see that if I do that, right, I store everything in a variable called Y underscore grade, right, which is just a grade of the Y test and then the Y print. So you can see the stack over here. Don't forget there's a brick here. I mean, this is around 4,000 of them. All right, so you can see them side by side. I'm able to predict where it is N. I'm able to predict N, right? Alright, you can see that when it is N, I'm able to predict N. When it's V, I'm able to predict V. When it's I, I'm able to predict V. Regardless, I mean, there are some misclassifications over there. That's why I'm doing 92%, which is quite good, right? Most of them I'm able to predict correctly, right? With I mean, just a few of them that I'm not. Maybe it was a T and I predicted, say, B, right? So I mean, in that case, it's going to be a wrong classification, right? So that one will actually comprise the 8% that I was not able to predict right. Okay, so but you can see that most of them I was able to predict correctly. Okay, now what I'm going to do is to actually create a confusion matrix where we can actually see these predictions, right? We can actually see, so this is what we, at the end goal is, this is what we want to finally do, right? We're going to create a confusion matrix like this, and then we'll have a label like this, which is going to be the original label, right? The original ones, right? Just like you were seeing me stacking them side by side over here. So the original ones versus the predicted ones, right? So I want to do them like that. So I want to create a label for this, right? And then the predicted label. So this is just the names that I want to create. These are, I mean, some names that labels that I just want to create so that I can compare them, right? So I want to create these labels, these ones that you see here, this label, I want to create that. Then I want to create this label here so that I can actually see them side by side and then see which ones I'm predicting right and which one I'm doing right. So visually, I can also see that. So that's what I'm actually going to do. So in order to get the label, so this is nothing but the label, right? So I'm going to create letters from uppercase letters from 26 uppercase letters, right? That is from A to Z, right? I'm going to actually create 26 uppercase letters, that is from capital A all the way to capital Z. Okay, so that's what this is going to do. Then I'll store everything in a variable called lab, which is label, label, right? Everything in a variable called label. Okay, so I'm using this as the uppercase function to actually do that, to create that. And then after I created this, right, so I'm going to get A, B, C, D all the way to Z, right? So now what I'm going to actually create here is that I'm going to create the predicted label too. So this one is I'm going to use this for the original label, right? And I'm going to use this for the predicted label. So I'm just going to add predicted in front of each of these letters, right? I'm going to just add. So if I pick A, right, I'm going to use predicted. I'm going to just add the word predicted in front of A. Okay, so each of them, if I pick say B, I'm just going to add predicted in front of it. Okay, that's why I'm going to, you can see over here, I'm just going to add the word predicted, and then you can see that I'm going to loop through this lab, that is this A to Z that I've created, right? So if I pick S for S in this, so this is just a variable name, so it could be I for I in this. So I'm going to loop through this lab using the for loop, right? So if I pick A, I add predicted in front of it. If I pick B, I add predicted in front of it. If I pick C, I add predicted in front of it, all the way to Z, right? All the way. So I'm going to do that all the way to Z, right? If I pick Z, I add the word predicted to it. So this is going to be the labels that I will use at the predicted label, and this the original ones are going to be the original data that I have. Okay, so that's basically what you can actually see that I'm using. I am having predicted A all the way to predicted Z, and then I have the original ones A all the way to Z. Okay, so basically that's what I'm doing here. Then after that is done, what I'm going to do, so if you see the lab, right, or the label, you can see that it's having A all the way to Z, right? That's what I was able to create over here, right? That's what I was able to create over here. I was able to create all the way from 26 letters A to Z. Okay, and then I was able to add predicted in front of each of them. That is going to be my plab over here. So that's what you can actually see, from A, predicted A all the way to predicted Z. Okay, that's what you can actually see. Then after that, what I'm going to do over here is actually create a confusion matrix, right? So from sklearn, right, from sklearn, I'm going to import matrix, right? And then I'm going to use Seaborn to actually plot this. So you can actually see that I have CM, which is nothing but confusion matrix. I'm just creating a variable CM for confusion matrix, right? Then since I have imported matrix over here, I'm going to use matrix because inside the matrix I have confusion matrix over there. All right, then I pass in my Y test and my Y print, and then the labels that I'm going to use is going to be the lab that I created, right, which is the label A to Z that I created, right? So that's actually going to be these labels that you can see over here. So that's going to be the original one, right? Then after that, what I'm going to do is to create a data frame for that, right? So I'm going to put everything that I've done here into a data frame, right? So I'm going to create, I'm going to use pd.dataframe, then I pass in this that I pass him the confusion matrix that I created, right? I'm just going to pass that confusion matrix over there. Then for that, the index label, right, which is this one, right? So in the index label over here, right, is going to be the lab, right? So that's characters A to Z, right? And then over here, the column label is going to be the P lab, which is predicted A, right? Which is also predicted A to Z, right? So that's basically what you can also see, right? Predicted A to Z. Okay, then after that is done, I'm just what I can do is to just plot it, right? So for that, I just set a figure size of 13 cross 10. That is the length over here should be 13, right? So let me show you in this way, right? So over here I have 13 over here, right? I have 13 over here. Then I have over here 10. Okay, so this is basically what I have, right? I have 13 right? Then I have thing. So I set a figure size like that. All right, then after that one, that is done, I'm going to use a heat map to plot this heat map, right? To plot everything over here. So you can actually see that I have let me zoom a little bit out. Okay, now you can actually see that I'm using a heat map over here, which is present in Seaborn. That's why earlier on I imported Seaborn over here, right? So I'm using that's one over here, right? So you can see that I'm using heat map present in Seaborn, and then I'm passing in my my data frame of the confusion matrix that I created over here. Okay, then I annotate equals true because I want to see these numbers present on top of the heat map, right? And then I'm formatting it as G, which is nothing but the green color that you can actually see on the diagonals here. Okay, I'm using this C map, which is nothing but the color map. So there are a lot of color maps that you can see. If you see the documentation for heat map, you can actually see a lot of different color maps that you can actually use. Okay, so that part is done. Now let's have a view of what this is actually telling us over here. Let's see our confusion matrix itself. Okay, now if you see the confusion matrix, if you see the diagonals of the confusion matrix, you can see that we have this over here, right? You have the green diagonals over here, right? You can see that. Now let's see the values over there, right? Let's see the values over there. Now what this one is telling us is that, don't forget that I said that this part is the original, right? So I have let me write it here for you. This is the original letters that I was having, right? And this part is the predicted one, right? This part is actually the predicted, right? The predicted one, the predicted letters that I have. So you can see that I was able to predict, if you pick say A, right? If you pick A over here, let me bring a line over here. You see that A and then A. You can see that A and then if you trace this one down, you can see that A and then A, right? And the predicted A, right? I was able to predict 144 of them, of the A's as A, right? In the same way, if you pick say B, right? If you pick B over here, I was able to predict 127 of the B's as B, right? I was able to predict 127 of the B's as B's. If you pick say K, right? If you pick say K, you can see that I was able to predict 131 of the K's as K. Okay, so I mean most of them I was able to predict them right. I was able to predict majority of them right. I mean as right. I was able to predict majority of them as right. Now regardless of that, you can still see that I was making some little mistakes over here. If you, for example, if you pick P, right, this letter P was predicted as F, right? It was predicted as F instead of predicting it as P, right? It was predicted, so 11 of the P's were predicted as F, right? And you can see maybe you can see, if you pick say H, you can see that seven of the H were predicted as D, right? As D instead of predicting them as H. Okay, so that's why I mean the accuracy was around 92%. It was not 100%, right? It was 92%. So there were around 8% error in there, which is quite fine. I mean 92% is quite good, right? Where our model is actually doing very fine over here. Okay, so basically that is what you can actually infer from this. So our support vector machine is actually being able to classify these letters quite correctly for us. All right, so in the next video we're actually going to consider what is called clustering, right? We're going to talk about unsupervised machine learning. So so far we've been talking about supervised machine learning algorithms. So we talked about linear regression, we talked about logistic regression, we've talked about support vector machine, right, and some others that we've talked about. And then in the next video we're going to consider unsupervised machine learning, where we will start with clustering algorithms. Okay, so see you in the next video. Have a nice day.